Good morning, everyone. My name is Nicolas Roard. I'm a software engineer on the Android team, and I've been working on the Android WebView and, by extension, the Android browser for the last few years. So what I'm going to talk about today is mostly a bit of the under-the-cover mechanisms for the WebView, how we implemented the view. And the second part is mostly about how you can take advantage of that to make your application smoother and nicer to use. All right, so WebKit, for the probably very few that don't know what it is, it was originally an open source project by the KDE desktop environment, and they used that for their own browser. And Apple took HTML, that layout engine, and extended it and made it more robust, and use that as a base for Safari. And more to the interest for us, in 2008, both Chrome used an engine based on WebKit, and the Android used both the browser and the WebView, also using WebKit. One of the interesting things with Android is that the Android browser is actually just using the WebView, so it's exactly the same thing that you are using or that you can use in your applications. Okay, so let's talk a bit about the architecture. So WebKit. So roughly, you've got two parts. You've got a layout engine, something that can take some content and determine where it wants to put the various elements. And you've got JavaScript core, which is a JavaScript engine that will do whatever it wants on the page. And those two things are regrouped under the umbrella of WebKit. Right, so how it works slightly in more details. So let's say that you get WebKit. You are going to get some resources. You're going to send them to WebKit, or WebKit is going to load them more exactly. WebKit is going to build a document object model using that, execute any JavaScript that has to be executed on the document object model, and finally do the layout and everything that needs to be done. So what is interesting to us is that WebKit is actually a very abstract engine, and the platform-specific bits and stuff like rendering are nicely put into the category platform. And from that, you can get the final rendering. Right, so in platforms, what do we get? So we have the network and disk access, of course. You have some system integration, and about that, I'm mostly thinking about the newest HTML5 APIs, stuff like camera access or geolocation or whatnot. And of course, that's platform dependent. And the big part of this talk today is going to be more about the graphics and the rendering, because that's really where you can see a difference between the different WebKit implementations. And finally, you can also possibly replace the default JavaScript engine of WebKit by something else, which is actually what we did. We are using V8, the same engine as Chrome. OK, so quickly about the system integration. Those are some of the APIs that we added on previous releases of Android. I think if you're using the WebView in your application, the thing that you can be interested in are the HTML5 video support, and the geolocation API. But anyway, roughly every release we try to add more support for those kind of APIs. All right, about JavaScript, just to give you an overview. On the same device, you can see that, well, luckily, we improved from releases to release. And in Jelly Bean, on the Nexus S, you are a bit more than twice as fast as Gingerbread was. Interestingly, if you compare that to a laptop, and that's a 2.5 gigahertz Core 2 Duo, the Galaxy Nexus, it's only 5 to 6 times slower, which, if you think about it, is not that slow. I mean, we are getting closer and closer to performances that you got on a desktop a few years ago. All right, so rendering. And again, that's mostly where things differ in terms of the WebKit implementation. Everyone is using WebKit. WebKit is used by so many different companies. And where things differ is how you implement the platform-specific bits that decide how you want to render stuff on screen. So if you remember that, basically that corresponds to something like that in terms of a rendering loop. You got, let's say, an event, like a scroll. You are going to, in reaction to that, paint something, like a bitmap in memory or something like that. And that's going to be your content. And finally, you want to draw that content on screen, right? And of course, you do that over and over again. Visually, that corresponds to that. Let's say that you got your document. We are going to work with what we call the viewport, which is simply the visible part of your document. And actually, I lied. That's exactly how WebKit sees things. Is that nothing that is not shown on screen is actually painted. You only paint what's visible. So the problem with that is, if you scroll around, you have to repaint this area. And that's an issue on mobile, because it's a very tight loop, and it can be slow. So what we did on Android before Necomb was, instead of implementing this action reaction of repainting stuff as we were going on, instead we capture the content of the page into what we call the picture. And then, using that picture, we can render it. Okay, so why did we do that? Because the picture is basically a vector representation of the page, which is nice, because then it means you can do stuff like scrolling, just by moving the transform of when you replay the drawing instructions, or you can zoom without having to go back to WebKit. And that's good, because if WebKit was only doing painting, that would be fine. But WebKit, of course, is doing a lot of other stuff, loading documents, doing layouts, anything like that. So if you depend from WebKit to get reasonable performances, you may stutter, because you're going to send an event to WebKit saying, hey, repaint me this part of the screen, and WebKit says, sure, but hold on, I'm doing something else. So by having this split architecture with the picture and on one side and WebKit on the other, we can do our things on the UI and let WebKit do its own things. So, and that's basically what it is, right? We've got two different threads, the web core thread and the UI thread. We have a picture that we use on the UI thread to render the page on screen. So if we send an event from the UI, like a scroll gesture or a flick gesture or something like that, we send it to the web core thread. Web core will generate a new picture, send the picture to us. We can then use that one to show the new content to the user. Right, so this is nice, but there is some issues. One of the main, and I believe that most of you have experienced that on your Android devices, is that the speed is dependent on the content. Meaning that on some websites, you're going to be able to scroll very smoothly, very, very quickly. The user interaction is going to be nice. And then you go to a different website, and the website is not responsive. And that's because of this, because we are replaying this picture, and if you have too many drawing instructions, or if the drawing instructions are too slow to rasterize, to get your final image, then you're going to take longer than 16 milliseconds, and you're going to be visibly slow. The other thing is that it's a purely 2D model. So if you want to support things like CSS 3D, you're out of luck. And the last thing is that, if you remember, with the plugins such as Flash, you could scroll around, and the Flash plugin was kind of trailing behind your scroll. And that's because it's difficult. It's an asynchronous rendering model, and it's difficult to synchronize both, because one doesn't know where the other is. Anyhow, on Honeycomb, we completely changed that. So the reason is because as screen size increased, the whole rasterization thing in software didn't work out. So what we did instead, we just tiled content. So the idea is that if you take that rendering loop, you really, really, really want that loop to be done in less than 16 milliseconds. That corresponds to 60 FPS. The problem with this is that if the paint, as I explained, takes longer than that, then you're out of luck. And visibly, you'll see something like that. You're going to scroll, but it's going to stutter. So ideally, you want something, I scroll, I draw, that's it. And that's basically what hardware rendering is. So starting from Honeycomb, the WebView, as long as the application runs in hardware accelerated mode, is going to use that mode. And what you do, you scroll, you draw, and you draw your tiles. And of course, what you do is you move things into different threads. When you scroll, you send a command saying, hey, paint me the new content, the one I just uncovered, and it gave me new tiles. But the nice thing, of course, is that as it's done in a different thread, if that operation takes time, it really doesn't matter. So here is how it looks visually. You got a viewport. We are going to prepare some new tiles. We are going to use them to display the content to the user. If the user is scrolling, we prepare some new tile, but we don't have to wait for the rendering loop, right? So we can just start scrolling around, even if some of the tiles are not there, doesn't matter. We can take the tiles that are now hidden and reuse them to get some new content. So that's roughly the general idea, and so on and so forth. In terms of the architecture, we just add the new thread. When we create a picture on the WebKit thread, we send that to the UI, send it to the texture generation thread, use that to generate the texture, send the texture to the UI, and the UI can directly use those textures, and that's it. The nice thing with this model is that, again, we are completely separated from WebKit, and we can be completely independent, so we can still do all the zooming, scrolling, and all that without having to go back to WebKit. We still have the entire page content inside the picture, so we still take advantage of that to be able to generate tiles very quickly. So the problem with this is we are basically doing exactly the same job as before, and on top of that, we have to upload the content to the textures. So basically, you're going to get slower painting performances with this architecture, but you're going to get much faster drawing performances. Obviously, to try to hide that, we do a lot of things, like we try to pre-cache the tiles in the direction where you're scrolling. We schedule some tiles that are at a lower resolution so that they can, at a lower cost for us, cover a large area. So that's why on the browser you can see some blurry content sometimes if you scroll too fast. But at least we show you something. And of course, we are limited by the memory, and that's dependent on the device. One thing that I'll talk about later, but you can think about is the tiles are 256 by 256 so far, and that has some implication in how you can use that to tailor your content. One thing we do in Jelly Bean as well is we do some check. If the tiles are completely empty, we don't use a texture for that. We just use drawing shader, and that saves some textures, and that improves some of the performances. Okay, so that's the rough idea on how WebKit works in terms of drawing. And then someone decided that, oh yeah, but we can create this thing called layers. So layers, the general idea is that you got your page, you got some content on the page, and you scroll that, right? You want to translate that element, you want to animate it on screen. If you do that, what's going to happen is that, think about it as a base surface, and you are going to have to invalidate and repaint this entire surface, this entire area, on the surface, because that's where you move stuff. And it's even worse because you are not doing that in a single frame, you are doing that in as many frames you need for the animation. So the idea with layers is to say, well, let's get that element onto its own surface. So now we don't have a single surface, we have multiple surfaces. And then we can just draw that at draw time when we want to show the content to the user. And if you think about it, if we do that in OpenGL, it's nearly a free operation. We just draw different quads, and the GPU card is doing the heavy work. And stuff are smooth. So that's the idea with layers. The other thing that you can do with layers is better integrate with, or better support some of the HTML content. One example is this, right? You got a web page, you got a video on the page, and you got this bottom section with images that you can scroll around. The normal model would be for the scrolling around, every time you scroll around to repaint this area. And that's not super fast. And if you have this hardware rendering pipeline, it's even slower because, well, on top of everything, we have to upload the texture. So what you do instead, you take those two things, the video and the scrollable element, and you move them out of the base surface onto their own layer. The nice thing is that for the scrollable layer, you can then not just paint or pre-paint the stuff that is currently on screen, but you can paint the entire element. Then you just have to clip when you draw it, and that's it. The nice thing is you don't have to go back to WebKit, you don't have to invalidate, you don't have to repaint, and things are smooth. Right, so on this previous page, this is how it would look like in terms of WebKit. You would have the base surface, the base layer. You would have one video layer, clip layer, and scrollable layer. The good thing with the video layer is that if you remember what I was saying or explaining earlier about the Flash plugin, you want stuff to be synchronized. The problem that we had before is that we didn't know where it was, or we knew too late because the rendering was asynchronous. In this model, we just say, oh, well, be on your own layer. And then it just happened that when we draw this layer, we're not using the texture. We are directly, or more exactly, we are directly asking the media server to give us a video texture, and we show that. So we control entirely where things are, and therefore things are fully synchronous. All right, so layers, basically, they are great. And if there is one thing you should remember about this talk is use layers. And I'm going to go into more details about how you can do that in your application. But basically, as I explained, you can move them around, and it's very cheap. And what I said before about the foreign content. All right. Originally, the idea with layers was not even that. The idea for layers in WebKit was to implement CSS 3D. So CSS 3D, for the one who don't know, it's something like that. You got some 3D transforms that are applied to elements. So here, for example, all those little rectangles are just div elements. You just apply a CSS transform, and that's it. Just another example, got a rotating cube. And you can do all kind of fun things, and basically you can use that to maybe make user interface more or nicer to the user or more interactive. Anyhow, on Android, we implemented the support for that in the WebView since on Acorn, but we also used it to do other things. So what we did for the architecture, we basically took the previous architecture, and we said, OK, instead of giving us just a single texture, give us a tree of layers, and each layer will contain, I'm simplifying a bit, but each layer will contain a picture. The thing you notice here is that I did the CSS animation. So CSS animation, it's a pretty cool thing. It's something that lets you specify an animation in a decently high-level way, and you can do pretty complex things. It's supported on Firefox and WebKit-based browsers. The nice thing with that is that instead of letting WebKit doing the evaluation for the animation and determining where you want an element to be according to that, we can take this computation and move it to the UI. And basically, that means that those animations are hardware accelerated. Oh, sorry. And if you have heard a bit about the World Project Butter and stuff, that also means that those animations are desynced. So they are nice, smooth, and of course they are much, much faster than JavaScript. You don't need to execute anything. It's all done on the UI side. It's all synchronous. Yeah, but to simplify things, try to use CSS animations. For example, on this example, sorry. The way you do that, you just create an animation, say where you want it to be, and apply a transform. And that's all. And that's what was giving you this spin thing. So on Android, we used this concept of layers and leveraged it to make the content nicer. So one pretty simple thing that we did, and that was back in Froyo, was to support fixed position elements. And fixed position elements are those elements on the web page that basically don't move when you scroll around. And we implemented a bunch of other things, like the HTML5 video, the iframe support, overflow scroll element, of course the CSS 3D, and even fixed background elements. So that gives you something like that. If I take the iWebsite, you got this fixed element, and you see that it's scrolling smoothly. And the reason is because that element on top is a fixed element. We don't have to go back to WebKit. We can just do the compositing and the positioning on the UI when we want to draw a frame. But that's just the fixed background element. I mean, it's basically, sorry. You can see that the background of that element is actually another image. That image doesn't move, and you can still scroll around. Anyway, you can do a lot of interesting things. Basically, what we're using is the same code path as for the base layer, what I was describing earlier. And we have the same constraints. We try to do a couple of clever things to help you with that, because if you generate too many layers, that can be an issue in terms of memory. So we try to merge layers if we can, and a couple of things like that. All right, so that was all about describing how stuff worked internally. Now, how can you take advantage of that to make your stuff faster? So basically, the WebView is something that lets you display some HTML content. You can consider that it has a desktop HTML support level, and it can do all kind of cool stuff, right? Yeah, that's basically what we added on the different versions. Let me go quickly because I think I'm running a bit late. So you use that basically like a normal web view, like a normal view. It's just another widget. If you want to load content from the internet, you have to use a permission, obviously. You may have to override the WebView client if you want to do that. Loading content is as simple as specifying a URL or injecting some HTML directly. You may want to enable JavaScript. And basically, in terms of the rendering, you got those two different modes. You got this hardware rendering mode that I was talking about. You still have the software rendering mode. And it's still there for a reason. Sometimes it's going to be much more memory efficient than using the hardware rendering. Basically, if you have content that's not very large, you are not going to be taking much advantage of the wall tiling architecture. So if your content don't move, you don't really care. And in that case, it might be much faster, and even at repainting stuff, than using the hardware acceleration. So it's not a free lunch. If you want to use that, you may actually, if your WebView is very large, we still have to allocate a back buffer, so you are still going to use some memory. So in some cases, that may be a wash. Bottom line, if you don't have too complicated content, you may want to use the software rendering. It might be a better idea. You lose some things. You don't have CSS 3D or inline video, but that might be OK. Right, how do you get the hardware accelerated view? Well, if your application is accelerated, the web view is simply going to be asked to be drawn onto an accelerated canvas, and from then, we know what to do. If you want to force the 2D rendering, so let's say that you have an application that is hardware accelerated, which I hope you are, you may just want to specify the layer type to software just for the web view, and that's going to trigger the 2D rendering code path. So one nice thing is accessibility is supported. So if you want to have accessibility in your application and you have a web view, you basically don't have anything to do. Just one thing, try to enable JavaScript, because then we support more things like explore by touch or gesture navigation. And it's basically the same solution as Chrome or Chrome OS. So if you want to make your content accessible, you can test that on Chrome. It's going to work on the web view as well. If you want to implement inline and full screen video, one little gotcha, and that's why I'm talking about it here, is that we don't know how to display the full screen mode, right? We are just a normal view. So if you tell us, OK, I've got a video and I want to display it full screen, we don't know where to put it. So you have to specify or to give us a view, and when we go to full screen mode, will just redirect the video texture to that one. So that's how you do it. You create, you just have to implement the onShow custom view and the onHide custom view. The interesting thing with the WebView is that you can bind the JavaScript code to your Dalvik code. You do it in a very simple way. You create this class, and here I'm just defining this showToss method, right? And that takes a string as a parameter. And that's going to just, if I call that function in JavaScript, it's just going to show me this little toss message on my application. How do you bind that? It's very, very simple. You just create an instance of that class, give it a name. So here that's Android. Add it to the WebView. And from then on, if you call Android.showToss in JavaScript in your WebView, that's actually going to take that bridge and execute the Dalvik code. All right. You can use the Viewport tag as well. That's a nice way of specifying things like, are you letting the user zoom or not in your content? So if you have a web app and you know explicitly that your content is not going to be zoomable, maybe you want to prevent the user to do that. That's going to provide a better integration with your app. You just do it that way. There's a bunch of other parameters that you can use, but you know the documentation is there. Let's talk again about the layers and the animation. Basically, try to remember, use layers. And you know, if you have been to some of the other talks about Android, this is exactly the same problem and the same solution for the hardware acceleration on the Android application. So a typical way that you would animate some content in a web page, or I mean in your web content, you get the element, you know, you change the left and top of that element. And that's basically the worst possible way that you can do something. What you can do instead is move that to a layer. And you can do it very simply by just applying a CSS transform 3D, even if it's, as here, a completely empty transform. That's going to move that content to its own layer. And then, you know, moving it around is going to be much faster. Ideally, you don't even use the left and top, because the left and top may trigger some relayout in WebKit. So just use a translate 3D with the right parameters, and that's probably the best way. So as an example, if you want to take this and move it like that on the right, how do you do that? Well, in JavaScript, you would do something like that. And basically, you know, you call this run function, you set a timeout so that it's called again, you get the delta, you see how much pixel you need to move, and you specify the left element. So two things here. First, it's actually a pretty complex piece of code. Second, it's going to be really slow. So if you try it on your tablet, it's going to be something like that. And the reason is because you are going to have to go to WebKit. WebKit may be busy doing other stuff. We have to generate new content, send it back, repaint. It's not optimal. In CSS 3D, or in CSS animation, that's how you do it. That's, to my eyes, it's much cleaner, much more readable, and it performs a lot better. So that's on the same Zoom tablet, which is not the fastest device in existence, and that's actually running on Honeycomb or ICS, I don't remember. So the CSS animation basically gives you a much faster content. It's V-synced, it's higher level, and you can do pretty complex animation as well. And the way it works is because basically, for elements that are animated, you are going to create a layer, and as we saw, layers are much nicer. So you can do complex animation like that, and that's very easy to do. You just set up for each element a small animation. You can imbricate things. It's really nice. So I talk about layers, and you know, they are nice and all that. How do you get layers? Well, basically, you got a few rules in WebKit, and those are the rules. You know, if you apply a transform 3D on an element, it's going to be put onto its own layer, etc. For the video, for the canvases, for the CSS animation, all that is going to create layers. As I said before, on Android, we're actually using layers to do more things, right? So we got additional rules. So if you are using a fixed position element, bam, layer, and etc. Overflow scroll, and iframes, canvas, fixed background, all these things are going to create a layer. The thing to remember, though, is that even though they are on their own layer, this is a purely implementation detail. The content is going to be visibly the same if you don't use layer. It's just going to be much slower to render. Of course, I mean, if you're a CSS 3D, that's not going to work, but that's a special case. Because we don't do the transform in 2D. So basically, if you have content that you're animating, put it onto a layer. Now, the thing you have to remember is that creating a layer is not cheap, because you have to basically do two repaint. You have to remove that content from whatever surface it was, repaint that surface, then create more textures and paint those textures as well. So this is, all in all, it's a pretty expensive operation. So a typical trick is just, well, if you know that something is going to be animated, move it onto a layer, keep it there. I mean, above all, don't do all the, a back and forth all the time between I'm on a layer, I'm on a base surface, etc. The tiles are 256 by 256, at least for now, and you may take advantage of that. So if you know that, so if, for example, you use the viewport tag to specify that you are going to have the scale of 1.0, you can then make sure that your content is going to fit on just a single tile, and that's going to be much faster than if you are just one tile and half of another. It's not, you can't always do that, but if you can, think about it. There is a slightly different code path for images. If you are using images, and let's say that you are using lots of images, you may want to apply the translate 3D directly on the image element, not on the div that would contain that image. And that basically let us just get that image, and we can reuse it, and we just have to render it at scale 1. And we let the GPU do the scaling. And as I said, you may want to try the software rendering. That might be nicer. But I said that you should not use JavaScript. We still did improve stuff in Jelly Bean, so stuff are not as bad as they were. But yet, I would say if you can use CSS animation, much nicer. All right, so one of the typical issues that people have with the WebView is synchronization. And by that, I just mean, how do you synchronize what you are showing on screen with the Java stuff? And so if you remember that previous diagram, we get an event, we create a new picture, we send it to the UI. Before, when we were just using the 2D rendering, we were receiving that picture, and basically we could just draw it instantly. So we had this onPicture listener callback that is not deprecated, that when you were receiving it, you would know that, OK, that's the new content. But now, of course, things are different. If you create your picture, we send it to the UI side, you get that onPicture change, but between the time you receive that and the final rendered content, there is a delay. And sometimes that's not great, because how do you know that what you send to the WebView is usable, is binary rendered? So the solution, well, we don't have an API for that, but we have a solution that actually works everywhere. And that's by using the fact that the CSS animation have to be synchronized. So what you do, you create a bridge object. So here, we just add this finished rendering method, and we just add that to the WebView. And the simple test case here is, I've got an application, I'm having WebView, and I'm loading the content in my WebView, and I want to show some text before the content is displayed, saying, oh, the content is loading or something like that. When the content has been loaded, you can remove the text. And that's what the finish rendering method does. You just set the visibility of that text view to invisible. So we just create an instance of that, add it to the WebView, call it Android. And the CSS Magic is here. You are going to create two CSS rules for an element. One is just to move that element to a composited layer, so we'll use that code path. The second is to say if you are of the class finish, do a slightly different translate so that we will wait for that transition to happen. And we have, for internal reason, you have to give something more than 0 milliseconds. So if you got that, on the HTML side, that's how it would look. You would have your content, you would put your transition element, for example, at the end of the body, so you know that the rest has been loaded and blah, blah, blah. And when stuff are loaded, you call load. That's a very simple example. If you have more complicated content with images or things like that, you may want to have JavaScript handler on the onload event of those images. You get that, and the load implementation is basically saying, when I'm loaded, set the class to finish, and add an event listener to that element. When the WebKit transition has finished, then you can call the finish rendering method that we define on our bridge object. And basically that says to us, okay, when you're loaded, use this CSS finish rule, and when that rule has been fully executed, and we know that because we got this event WebKit transition, and then we call the callback. And like that, you are synchronized. All right, so let me talk a bit about the debug, because it's, okay, you got all this, how do you debug that content? There's a few things. First thing you can do, you can use the console, the old school, just output printfs in your ADB logcat. You can do that in JavaScript. If you get ADB logcat, that's how it would look like. So of course you can do all the typical stuff in logcat, filter, and whatnot. You can actually specify or use different logcat levels here, the same as you would in Java. One thing you can do, though, is you can intercept those message calls for your WebView, and then you can do whatever you want. All right. One thing that's pretty useful is, if you are into testing, is Selenium WebDriver. And it basically provides you a testing infrastructure for your HTML content. For mobile, the nice thing is that it supports the touch, gestures. You can take a screenshot, compare it to a previously taken one, so you know that your tests are going to pass or not. And more information are there. The way it works is pretty simple. That's an example of a test case. You create a WebDriver, tell it to go here in the, we just opened google.com. We look for the web element. We can send keys, submit, and when we get that, we can get the result and assert that it corresponds to what we're looking for. So anyway, that's just testing the testing infrastructure. So if you have content that does, that not just simply present content, but are doing more interaction with the user, and you may want to look into that. The other thing that you can do is use the Android browser debug mode. So, I mean, if you try your new Nakazi, the Android browser is not there anymore. On your Galaxy Nexus, it's still there. So it's not a perfect mode, and we are working on it. But if you have the Android browser, there is a bunch of stuff that you can do. So the simplest thing is you can enable that mode. To do that, you just go there, type iboot:debug. You press enter, and that's basically going to, it's just a toggle. So it's going to trigger on or off this debug menu in the settings of the browser. And here you can do, there's a lot of interesting options. Probably the one you are interested in are US strings, so you can specify a different user agent string for the browser. So you can easily test if your content is really not working, or if it's just because the website is sending a different content, depending on the UA. The other really interesting thing, if you are trying to optimize performances, is the visual indicator. So if you enable it, that's how it would look like. And here you can see all the tiles that I was describing on the Google I/O webpage. If you look at the tile, that's basically what you have as useful information. You got the coordinates, you got the scale factor, and as I said, there is in your web app, you may have some interesting optimization to be made in terms of with the scale factor, so you can tailor the images that you are showing or things like that, and prevent user to move to zoom around or using the viewport tag. And the last thing is just the painting time. That's a CPU time, so that does not account for the entire pipeline, but that can be interesting if you see that some of your content is very slow for whatever reason to show up. That could give you some hints. The other thing is some of the elements, like fixed elements, are shown in a different color. So if you remember that IO web page earlier, that was showing the scrollable, the position element, sorry. This is just using a red, slightly tinted red background. And the other thing is, you can see, if I take this example and I zoom, that the tiles for the Android are actually at scale 1, while the rest of the tiles are at scale 270, which is the scale I was zooming at the time. And that's because we've got this optimization where if you only have image on your layer, we are not going to go further than 1x. So that's, again, another optimization that you can do. You got a bunch of debug commands that are pretty useful. One of the nice ones is render tree. That's going to basically create render tree.txt on your SD card. You can grab that using ADB. And that's how it looks. It basically shows you the rendering tree of WebKit. So that's a bit involved, but if you want to really debug stuff, that can be quite useful. The other interesting one is the layers tree. And that's actually a problem in general with browser and in our case, the WebView, is that there is no good debugging tool for layers. We provide at least this, which is just give you the tree of layers. And if you look into it, you can, for example, look at the layer ID. And this is a fixed element on the Google I/O web page. And you can see because there's just fixed left, fixed top, fixed right, and stuff. But if you look at the layer ID, that corresponds to that blue number on the layer. So that can be helpful. It's not optimal. We can definitely do things better. But there is definitely a lack of a good tool to deal with layers and stuff like that, even on the desktop. Just as an aside, as we're using WebKit as well, if you do stuff in Safari or Chrome, and you use their debug tools, it's probably going to go a long way in terms of debugging your content. But you don't have you don't know the layers architecture is not exposed. So anyway, one thing that we are working on, but it's not ready yet, is to actually not use that anymore, but instead we're going to leverage Hierarchy Viewer. And if you don't know Hierarchy Viewer, definitely look into it. It's a really nice tool that basically lets you connect to your application and explore the view hierarchy. So what we'll do is that when you have a web view, instead of just showing this rectangle saying web view that's not so useful, you can see here that we can show the entire tree of layers. You got a bunch of information about the layers. You can grab the content as well. And all kind of interesting things. And that's it. So actually, I was faster than what I thought. So if you have any questions, the microphones are on the aisles, and you should just go to the microphones.
Sorry, in Jelly Bean, if I make a web app just for Jelly Bean, would the WebView use the Chrome for Android?
No.
No, still use the old browser rendering and all that?
Yes.
Okay, great.
So, the reason is pretty simple. The WebView is part of the platform, and Chrome is on market. So if you update Chrome on market, we can't replace the implementation of the WebView. And even if we wanted, we might not want to do that because that could break compatibility. So, yeah.
We are using app cache within WebView. So different OEM I'm seeing update even some OEM it's on the same level. For example, Honeycomb or Fryo, same version level, but different OEMs browsers triggers update ready event. Some of them don't. So it's very difficult to implement this app cache within the WebView. Have you know this problem, or is it something you guys working on?
I'm not sure I understand the question. It's about triggering the events on app cache?
Yeah, update ready event, so we can refresh the page so with the new content within the WebView. So if you rely on the update ready event, right, then I can refresh the whole view, so I get the new content on the browser. But some of the OEMs, I see update ready event is not firing. So it's on the same Fryos version, but different OEM has different ways that update ready even fires.
I'm not sure. Can you come to see me after the question?
Right.
Because as far as I know, things are working, but we can look into it.
All right.
Hi, I have one question. Can I use the DEV tool of my desktop browser to debug the WebView in my phone?
So you mean
The
you mean
USB web debugging.
to use your debug tool to connect directly to the WebView?
Yes.
That's not doable. But as I said, if you're using a browser on your desktop that's using WebKit, we are using a recent version of WebKit as well, and things are pretty similar. And there was a lot of things that we improved in the latest version on ICS and Jelly Bean. So we are very comparable to a desktop browser. So if you try stuff on a browser, it should work pretty much the same on the WebView, with the caveat of all those performance and the various tricks that I explained today.
Okay, thank you.
Hi, right now you guys have the ability to synchronously call from JavaScript into native code. I was wondering if you're going to be able to do that in the reverse, sort of like on iOS, there's the ability to get string by value in JavaScript string, and you can get data from JavaScript into native. I was wondering if you're going to implement something like that, or planning on Android.
So I mean, the way you do that, I mean, you can use the bridge object, right? And you can just pass a command to to whatever you define in your class. If I remember, the data type that we do support are strings and stuff like numbers. But you can pass some content from JavaScript to your Java UI that way. In terms of synchronous, that's probably not something that's not the case right now. And going forward, that's very likely is not going to happen because in general, you want to have an architecture that is asynchronous. Otherwise, you are going to possibly pause the UI, and that's not going to be great in terms of the user interaction.
Okay, thank you.
Hi, I have two questions. The first is, during your presentation, you were talking about adding something on a new layer. Do we have to do something on the DOM structure before, or just applying a CSS3 property is enough?
Yes, so basically you got those various rules that's going to decide, okay, I'm going to take that element on my DOM and move it to a layer. And the typical one that are in WebKit, and that by the way is actually true of any WebKit-based stuff, right? Both on mobile and desktop. The only thing that that may not change the rendering, but if you do a translate 3D, those are the common rules in WebKit, and that's going to move that element to a layer.
Okay.
So that's all you need to do. And the typical trick that I've seen people using is just to do a translate 0, 0, 0. The one caveat is that it needs to be a translate 3D and not a translate 2D.
Okay.
But
and
that's enough to promote that element to its own surface.
Yeah, so everything is done by your brother. And the other question is very, very quick. There is no plan to port the Chrome DevTools on the browser, on the default browser, the WebView.
That's going forward. We'll see. But right now, yeah, I'm not sure.
Okay, thank you.
Good presentation. I was wondering, the CSS animation, is that all static, or can you dynamically change it based on user input?
Oh no, totally. I mean, here I just show example where you specify it in text, in your CSS file. But of course, you can add CSS styling from JavaScript, right? In JavaScript, you can manipulate the DOM and you can manipulate the CSS as well. So you can very, very well, and that's, I mean, most people do that. Is you respond to some user interaction, and you are going to apply a new style in CSS, and that new style happens to have translate 3D or whatnot. Okay. But as I said, it's generally pretty costly to get an element from a base surface to its own surface, to its own layer. So if you can keep things on layers, that's better, because then we don't have to do this back and forth. It's not always possible. You may have too many layers or too many. So, but if you can, that's something nice. That being said, we did improve by a lot the performances on Jelly Bean, but on ICS, even on ICS, that was not super great.
see. One more question. So it currently supports translation, rotation, and orthographic transformations. Any plans to support perspective transformations?
It works. It's supported since Honeycomb.
Hmm?
It's supported since Honeycomb.
Okay. Thank you.
Thank you for your presentation, and thanks for sharing this information. My question is it possible to proxy any web traffic via WebView?
That's a good question. I'm not sure. I think there's a few things that you can do with the webcom clients, but I'm not entirely sure that there are things that we expose with public APIs. Yeah.
Okay.
Okay. Okay. So yeah. Well, HTML, okay, so the question was, what about support for DRM protected videos? And that depends on the support for DRM protected videos in the HTML5 standard, right? So if you have, or when we will have something that's, works with HTML5 video, then you'll have an implementation. That's more of a WebKit question than, something for us directly. Yes. But, things are not built in one day, so.
One last question. Someone asked me this yesterday in office hours.
Okay.
If you have a view, like on a tablet, with multiple web views on the view, is there a way that each web view can have its own session? Because the cookie manager currently is a singleton?
Yeah. No.
Okay. Thank you.
Okay, well, thank you everyone. And if you have other questions, you can probably find me after the talk.